This is the Rhode Video Micro. It's a small, popular microphone used to improve the audio quality in DSLRs, and you can see that as I extend it away from me and towards the camera, the audio quality gets significantly worse. So I realized I needed to bring the microphone closer to me. The only issue is I don't have a stand for it. But what I do have is a Fusion 360 subscription and a bunch of 3D printers with plenty of PLA filament. So let's get started. The mic normally attaches to the camera via the hot shoe, which is the little rectangular cutout on top of most cameras. The only other thing you have to do is plug in the auxiliary cord into the side of the camera, then it's ready to go. So I started off by taking the measurement of the round threaded portion of the microphone, and it worked out to be around 12.7 millimeters. I also measured the rectangular plate, which worked out to be about 18.5 millimeters by 20 millimeters. The thickness of the plate was about 1.75 millimeters, but it was difficult to measure. So then I brought all the measurements into Fusion. I originally put the true measurements in, and then I did an additional sketch around those measurements to accommodate for tolerances so that everything would fit okay with 3D printing. Then I added the slot portion so that you could slide the microphone into position. You might notice that I go back into the sketches a few times to make adjustments. That's just my way of going through different variations. I don't do much hand sketching. I think that Fusion does a lot better job of drawing perfect circles than I can. So that's just my process. And then I do an extrusion here from an offset to make the slot. I made the slot about 2 millimeters so that the microphone would fit pretty easily, and then I could just tighten it down with that threaded part. And this is what the slot looked like when I got done with it. So this is where I started working on the legs. I didn't do any measurements for these. I just tried to make it proportional the best I could and felt like this would be decent size since it is a pretty small microphone. I actually started the profile sketch on the wrong plane, so I had to redefine the plane to make it in the right position. Then I used the mirror command for the other leg. Anytime you have a symmetrical part, I recommend using the mirror command because it saves you a ton of time modeling. So this is the final model. I wasn't sure if it would work initially, but I thought it was at a point where I could print it off and test it out. I wanted to be able to print this without support, so I made the back of the mount flat so that I could lay it against the print bed. I think this is where some people make mistakes when designing for 3D printing. In my opinion, it's better to have a more simplistic design that prints well than to have a more complicated design that's harder to print or that requires supports. I used my old faithful Prusa Mark III for this print. This printer with some Galaxy Black PLA is hard to beat when it comes to the quality of the print that you can get with the combo. The print turned out great with no notable issues, so this will be more than adequate as a functional part. Now for the moment of truth, does it fit? Here's some ASMR for you. Fits like a glove. Now just tighten it down and do an amateur torture test. I always hold my breath a little when I reverse engineer something to fit an existing part, but the time and effort is definitely worth it when an idea works out like you hoped it would. There's definitely something addicting about the sense of accomplishment that you feel when you create something of your own. I'll be using this in my videos going forward, so even if you don't see it in the frame, just know that this is how I'm getting that crispy audio on my monotone, deep voice. Thank you.